Hi, welcome to this live stream on visual prompting, where in the next 30 minutes, hope to share with you some thoughts on how you can build computer vision systems, maybe in minutes, using natural prompting interactions. Before I dive into the presentation, just one housekeeping item. On the YouTube video, under the video description, there's a link to a Slido link where you can ask questions during this presentation. So please jump in and ask questions at any time. At the end, I'll leave a few minutes to take people's questions as well. So with that, let's get started. I'm going to start presenting my screen. All right. So I want to talk today about visual prompting. And before jumping to visual prompting, I think we've all seen that text prompting has already transformed natural language processing. Say you want to build a sentiment classifier, take a phrase like, I love computer vision, and see if that has a positive or a negative sentiment. In the traditional machine learning workflow, you have to first get a bunch of data, get a lot of text snippets, label all of them with positive or negative sentiment, then train the classifier. Then after you've built a classifier, figure out how to deploy it, maybe in the cloud, and then use that to make predictions. So this would take, I don't know, days, weeks, maybe even longer. In contrast, we've seen with prompt-based machine learning that the workflow can be much faster. You can just write a text prompt, and many people are using this, for example, in ChatGPT, but just write a piece of text saying what you want, and then in seconds, get a prediction out. And what my team at Landing AI has been exploring, and many teams in computer vision have been exploring, is how to take this idea of text prompting and take this idea to visual prompting. So visual prompting takes the idea of prompting from text to vision. One caveat for today's presentation, a lot of people are using ChatGPT and Bard and so on successfully integrate effect, and those are direct-to-consumer tools. The presentation of today is more focused on prompting as a developed tool, that is, making API calls to prompt interface rather than as a consumer tool. So let me actually show you a concrete example of what I mean by that. I'm going to share a different screen. Let's see. Okay, so here's my code that to call the actually OpenAI interface to build a sentiment classifier using text prompting. So import OpenAI, just run that, load my API secret key, and then here's the prompt I'm going to use. So classify the text below, delimited by 3 dashes, as having either a positive or negative sentiment. And let's see, I type the text. I love computer vision. Getting computers to see is amazing. And then shift enter. And then this makes the API call. It took like a second maybe, and this prints out positive sentiment. And so in just a few seconds, you saw me basically build a sentiment classifier just by writing this type of text prompt. And if I don't like the result, maybe I wanted to just print out positive or negative and not print out positive sentiment, and go back and edit this prompt and keep iterating very quickly from there. So that's text prompting. How about computer vision? So here's a image. Let's see. Of a histopathology slide, right? Here's a pathology slide because a slide view under a microscope of cells and the disease and so on. If you were to want someone to segment out the cells in this slide, right, how would you go about doing so? So if a senior pathologist were to be sitting down next to a junior pathologist and be teaching them how to do this, it's difficult to use words to describe, an image like this. Instead, what a senior pathologist would do would be to say, hey, look at these cells, this area over here, the coloring in orange, those are the cells. And what I want you to do is maybe segment out these cells from these white regions. Sometimes it's called a lumen, basically, the empty regions, right, between the cells. And with a quick illustration like that, with basically a visual prompt that I just developed in a few seconds, you can kind of recognize what I want, what I might be trying to get, say, a junior pathologist to do. And in fact, in pathology, it's quite unthinkable for someone to learn to do this just reading text. All pathology textbooks teaching people to do this use images. It's just a much more efficient way to communicate what one might be wanting a system to do. So let me show you a demo of the software we've been working on to do this. Here is a visual prompting interface where I am going to use my mouse. I'm now doing this with my mouse rather than a stylus, so I'm not as facile with my mouse and my stylus. I'm going to say, all right, those are some regions that look like a cell body, and then this is the empty space, kind of lumen, so on. Right, let me shade in a few areas like that. And all right, that's probably enough. All right, took me about, I don't know, just a few seconds. And then I hit carriage return. Just like when you finish typing a text prompt into a system, you hit carriage return and then, you get back a result shortly. I developed this visual prompt that I just did it live in front of you. And then I hit carriage return, and this goes off to the model to see what it does, right? And typically this takes, I don't know, depending on server load, maybe it takes like 10 seconds or something. Let me just refresh the page, see how it's doing. Okay, awesome. Well, let me hide the labels. And it's not bad. So in a few seconds, we prompted the model, made an inference to separate out the cells in this kind of orange compared to the lumen or the other empty spaces in yellow. And it's not perfect, but if I want to fix it, I can go in and fix up some of the labels and try again. So this is a simple example of visual prompting. Let me show you another example. This is an example from life sciences. So life sciences, often given a petri dish like this, you might want to count the number of cell colonies growing in a petri dish. Those are these, little round things. And in a traditional object detection approach, this is an object detection system, you would have to label those round dots you want to find. So I'm going to label 1, 2, 3, right? And you can tell with a slide like this, it's going to take me a while to label there. I've labeled 5, and but I can't stop here. It turns out if I stop here and feed this a standard object detection system, I have a lot of mislabels because I haven't labeled all of these. So it's just really annoying, right? It takes a long time to label all the cell colonies, all of these round dots that I might want to find. Let me show you what visual prompting might look like. So I'm going to say this stuff here looks like a cell colony. Let me label this one as well. This stuff here looks like a cell colony. And then, here's some stuff, right, that looks like background. None of this is part of any cell colony, I guess. Yeah, there's some stuff that looks like background. So I labeled 2 cells, and let me hit carriage return again. And then the model will take just a few seconds to update and compute inferences. And let me show you the labels. And, not perfect, but pretty good, considering that it took me just seconds of work. And also notice this applies to new images as well, right? Just kind of generalizing this to some brand new images. So what I want to do next is show you the effect of how to then take a model like this and maybe deploy it, say in a Jupyter notebook, right? And so let's see. Okay. So here's my Jupyter notebook for visual prompting. I'm gonna run this, load my Landing AI API key, and then let me boot up the webcam. Oh, actually, let me start the deployment process. So I'm going to deploy the model that we just trained. So when I hit deploy, what this is doing now is it's taking the model, right, that we just came up with via the simple prompt, and it's loading the model to a cloud server, and then also setting up an API endpoint for us to make API calls. So this will take maybe tens of seconds, but while it's doing that, setting up this for deployment, let me go ahead and boot up my webcam. I have a second webcam connected to this computer. And so with me, I have a mocked up petri dish. This is not a real petri dish, so you can still want to spread germs around my office, but so this is that's my hand, you see, and so, all right, let me capture the image, and okay, good, it's finished deploying. Let me just make sure I have the right deployment endpoint ID. Yes, it's the same. So I'm going to take this image that we just captured and send it to the deployment endpoint. The first time we deploy a model, it takes a little bit longer, but with subsequent calls, it'll speed up. And then hopefully in seconds, oh, good. Okay, so return the result. And then my code is already returned. I'm now running the code to display the result. The code for displaying the result actually, maybe ironically, in this notebook takes longer than the code to actually, oh, good. And there it is, right? So that was the result that we just got by cloud inference of the model that you just saw me develop and train. I was testing earlier, that's why, but this is the image that we just grabbed, right, in the live studio, I guess, and showed you earlier today. These are other test images I was fooling around with earlier versions of the model. But we just went through that whole process of developing a model, prompting it, deploying it to cloud endpoint, and then taking a picture and running inferences and getting the result back in your Jupyter notebook. And you see me come back later to talk about how this very fast workflow, I think, has implications for how we approach machine learning. Just a couple more quick examples. Let's see. This is a satellite image from Sky5. So if I want to detect tree cover, I'm going to say, okay, this stuff, looks like tree cover stuff. And then this stuff here looks like ground. So let's run it. And just now you saw me do this with a pen and stylus. I'm a little bit more, doing it with a mouse a little bit slower. If you have a computer with a stylus, you can actually do this on the stylus on our web interface. And so that's the result and its performance on some new images. And I would say not bad, but not perfect. So even concepts like tree cover is ambiguous. It looks like there, I think that's a bush. From the lack of shadow, I think it's very short. So should tree cover include bushes or not? So if I'm not satisfied with the result, I can take these, data-centric AI iterations. It took us seconds to get the first model. I can now, relabel some of the bushes it got wrong. And then let's train another model and see what happens, right? And because it is so fast, in our earlier testing where users tell us that it feels like a conversation where you do something, the algorithm gives you a result, and then in seconds, you can say something else, you can give it another prompt, and then it gives you another result. Okay, now it looks better, right? So I prompted it, didn't quite give me what I want, fix up some labels. Oh, but then it looks like, got this wrong. So if I want, oh, sure, let's just do this too. I say, well, that actually looks like a building over there. So I can refine the labels a little bit, right? And then get a new set of inferences. And you can see me kind of literally working in front of you to prompt the model iteratively to get it to a better result. Okay, good. This is actually a pretty nice result. Now, it got rid of the building and knows that's not tree cover, and then we got all the bushes, right? And so on. So you just saw me iterate a few loops through the algorithm. One last example. LandAI has done a lot of work, continues to do a lot of work in manufacturing. And so in this example, we're going to prompt the model to detect cracks. I'm just gonna paint in, just a little bit of the crack here. All right. So with many manufacturing use cases, and as you can imagine, finding cracks is not an uncommon manufacturing use case. Okay, so I said, the purple stuff is a crack. The yellow stuff, that's just the surface of the thing. And then again, in seconds, let's see. All right. Okay, cool. Not too shabby, right? Looks like it did a good job on these. And then if we look at other images, it's like, okay, pretty good, right? And I can imagine working to improve it just a little bit, but frankly, this is a just fine crack detector that will be good enough for many commercial applications. So I bet you have not seen a lot of people build 4 different machine learning models in a live demo in just seconds. And I think this is possible because the visual prompting interface makes this really fast. So let me go back to my slides. Let's see. Okay. So I think of a visual prompt as a simple visual specification of a task, like the prompts that you just saw me use. There are many others in computer vision working on similar ideas. I just mentioned a couple of my favorite examples. Just a few weeks ago, Facebook/Meta released a model called Segment Anything that could be, when given an image, segment objects in that image. So an example of a prompt in their system, which is a very cool system, would be given a picture of a dog. If you were to mouse click in the middle of the dog, so that's the prompt. This, this point is part of a dog, or this point is part of an object, doesn't know it's a dog. Then it would segment out the dog. And also the Meta system had other prompts, such as a bounding box, and also experimented a bit with text prompts. So this is a very nice, simple visual prompt that then causes it to segment an object in that image, and it just works on the image that you prompted on. That's a very cool application. Another example, some work on Generous Painter and ChatGPT by Ryan and all the BAI, build a system where one example of the sort of prompt they use would be give it a picture and some visual key points, key points of, say, the person. That's the prompt, and give it a new picture, it would find the corresponding points on a brand new image. And experimented with other types of prompts. Again, this is a nice, simple visual prompt that allows the algorithm to very quickly do tasks. And then let's see, there was this paper out of, I think, Aloysia Effers's group out of Berkeley, Visual Prompting via Emission Painting, has some related in some ways to Generous Painter and ChatGPT, also very cool work. And then I also want to mention examples like visual prompt tuning by Jia et al., exploring visual prompts for data models by Bang et al. And I just want to point out there's some work that uses the term visual prompting in a different sense than I am today, where there's work in computer vision exploring if you have a neural network trained for one task, can you fiddle with the input, maybe tweak the input image or tweak the input tokens to get it to do a somewhat different task. So I think different researchers are exploring different things and so on. This is actually a lively field with many people exploring different ideas. I also want to mention that there is a related idea of using text prompts for image tasks, such as visual ChatGPT, the clip model. Actually, my team spent a lot of time playing with that, as well as the image generation models like DALL-E, Midjourney, Stable Diffusion, where you input the text prompt and get out an image. And what we saw when we analyzed many applications that Landing.ai's customers are collaborating with us on is that many vision applications use highly specialized images. For example, manufacturers will look for LCD display defects, and the vocabulary for finding LCD display defects is not normal English vocabulary, that words that I would normally know or use. And in fact, it's unimaginable, for a manufacturer when they're training up an inspector to only use text, explain to them what to look for these very different subtle shades of an LCD or little things that indicate a defect. The only way inspectors are trained to do this is with, visual communication, with pictures and examples, or otherwise human examples of the visual prompt of holding up something, showing them images, and using that to train people. And you also saw the histopathology image, difficult to describe in words, and even satellite imagery. Tree cover is relatively easy, although even there's some subtleties, and worked on finding other things in satellite imagery that are very difficult to describe with words. So I think words are certainly hopeful. They could be useful, but for a lot of visual tasks, I'm seeing use in practical use cases, the visual communication is much more natural and more efficient. Although I think text is great for common things. If you were to find, a hummingbird or something, then we have words to describe that. For a lot of applications, visual prompting seems to work better. And I think computer vision and visual prompting, it is at an inflection point. So let me share with you why now, why I think computer vision is at this inflection point. Looking to text, it was in 2017 that the Google Brain team and collaborators published the text transformers paper, now very well known. And since then, that led to rapid innovation in text, right? So BERT, GPT, NVIDIA, the Megatron LM, OpenAI, the GPT-3, T5. In 2020, OpenAI also had a beautiful paper on scaling laws, figuring out as you make language models bigger and train them on more data, how will they perform? Actually, a fantastic prediction for how language models will scale as you make them bigger and feed them more data. And then Lambda, GitHub Copilot, and so on. And then 2023, we're only partway into the year already. GPT-4, Bard, Bing Chat, right? Lots of progress there. And how about images? Well, it turns out in vision, the Vision Transformer paper, also by Google Brain, actually got published only a few years later in 2020. I remember reading this paper shortly after it came out, and it was a very interesting paper, surprising in the way it approached computer vision. But I think that moment then sparked off in subsequent years tons of innovations in vision, such as Dino, kind of a self-distillation model, shifted window transformers. Last year, 2022, a lot of exciting work on scaling vision transformers, slimming things down. Oh, there's actually an interesting paper exploring scaling laws for vision transformers, so distributional shift. And this year alone, you have Dino V2, SAM, ChatGPT, a couple of which I mentioned already. And I think that the development of transformers in vision, it is an earlier point. I don't think we have yet reached the GPT-3 moment in computer vision, but and I think many others in computer vision think that we're working, and that we will get to that, get there. And so I think progress in text and also increasingly in vision has been driven by large transformer networks pre-trained on large amounts of data. And the training is also, not always, but increasingly, I feel, is increasingly with unlabeled data or variations like self-supervision or weak labels, which lowers the barriers to data availability. So you train on very large data sets. And scaling up model size and data availability is often helping transformers generalize, given only a simple input prompt that, like the ones you saw, that hopefully, that only partially, but hopefully unambiguously specifies the task. So rather than needing to label every single cell colony, I can just label a few, and then it figures it out from there and is able to generalize. So over the last couple of years, motivated by these trends, we've been working on our visual prompting software. And I want to invite to the stage Mark Sabini. This project started at LandingAI when one day Mark pulled me and our head of product and head of engineering, Kai and Daniel, aside. Mark say, hey guys, check out this demo that I built. And in the last couple of years, we worked on this since. And let me just hand over to Mark to say a bit about the development of this software.
Cool, thanks, Andrew. So so we've actually been working on visual prompting since the beginning of 2022. And while we were developing it, it was really important for us to make sure that this thing could actually solve real customer projects. So luckily for us, we've been able to work with a lot of customers on their computer vision use cases. So what we did was we took 40 real use cases across manufacturing, agriculture, medical, pharmaceutical, life sciences, and satellite imagery. I want to analyze basically what percentage could be solved with visual prompting. So initially, we found that only 10% could be solved with visual prompting as is. But we really wanted to dive deep, and so we did a lot of customer interviews. And afterwards, we found that we just added support for simple post-processing. We could now solve a total of 68% of our use cases. So to kind of make it a little bit more concrete, why is post-processing so important? You can imagine maybe we're in a manufacturing setting and we're trying to do some part inspection, right? So one thing you might want to do is, take the output of visual prompting, which will say, what defect occurs in what location, and map that to an actual decision of whether we want to accept or reject the part. So armed with this knowledge, we basically designed and built a no-code post-processing feature to basically complement visual prompting. And the nice thing about this is it basically makes it so much easier to take that visual prompting model we can build and integrate it into an actual larger kind of system. So basically, here's what the first version looks like. So it'll be available for you guys to try pretty soon. And that's it for me. Back to you, Andrew.
Thank you, Mark. And it's been exciting over the last several months working with different users and customers on seeing how this does. So one example, Bob Chen, spoke with him just several weeks ago, is a senior director of engineering at Omnia, which does a lot of life sciences work. Here's a picture of his using visual prompting that he gave us permission to share, where there are a lot of cells here that he wants to find to decide which cells to try to do additional quantification on. So he said, in this project application, we need the segmentation master cells where the cells are, so we're going to do additional quantification. This is my highlight. He says, images at this dense on defects are traditionally very annoying to label. And with visual prompting, it becomes trivial. So she's very happy when he shared this with us, that went from annoying to becoming trivial. A couple other examples. Matt Shea does a lot of work in manufacturing at DH Technology. It's a longer quote here, but I'll just read the highlighted part. He said, development efficiency of such a complex project has been greatly increased. So work on 3D bin picking on like delicate contact lens auto sorting, and I was excited to see how development efficiency, Matt says, was greatly increased. And then one last example, this is a computer vision tech lead at a large pharmaceutical company working on a confidential project. So he gave us permission to quote him, but asked us to not share his name. But working on complex applications, he said, the time to develop and deploy a model is reduced from months to minutes, right, using Landing.ai's visual prompting tool. So we've been working with quite a few customers on this, and I was actually thrilled to see the number of examples where this makes developing and deploying much faster. Before I wrap up, I want to share some limitations and usage tips, and then some thoughts on how I think this will affect trends in machine learning. So one limitation of the system today is that it's better at distinguishing between classes based on texture and color than on shape. And this is a limitation of the pre-trained visual transformer, actually multiple pre-trained visual transformers that we're using that are better at recognizing texture and color features and on shape features. So this image I have would be like the worst case example, for the algorithm maybe, if you were to try to have it distinguish between cats and dogs just based on silhouettes. So if you were to try this, you can iterate, but it'll quite quickly plateau at a pretty low level of performance. So it doesn't work for everything, but on some problems it works really quickly. And then one usage tip. Taking a very data-centric AI approach to building these systems, and that means that our system is optimized for having only a few but accurate labels. And in particular, it tends to assume that every pixel you label is of a specified class, and so it is sensitive to incorrect labels. So we ask for very few labels, but we assume that you only give us clean labels. And what that means is if you're using it, it helps if you color within the lines. So when you saw when I did the Petri dish, demo, I tried to label the cells by coloring within the cells. Whereas if you were to go outside the boundary and tell it all that is a cell, then the algorithm will tend to get a bit more confused. So hopefully that's a helpful usage tip. And I'm excited about the prompting workflow because I think this has implications for how we build machine learning systems. And specifically, it helps us all to iterate much faster. In a traditional machine learning workflow, you have to get labeled data, maybe take a month, collect images, then develop model, maybe take 3 months to get that working. And it's an iterative process. So sometimes there's an error going back to get more labeled data. And then figure out how to deploy in production, take another 3 months to get it up and running. So, historically, it's often been this months-long effort to build and deploy a machine learning system. With prompt-based machine learning, you may be able to get a first model working in minutes, maybe hours. And if you can, sit down, get the model working in minutes or maybe hours, then won't it be frustrating if you needed 3 months, right? Like, to take 3 months. Like, imagine you log into the Landing.ai website today, get a model working today, then someone says, boy, maybe we'll deploy this in three months. That's frustrating, right? So I'm seeing a lot of teams work to figure out how to change the processes to deploy in production very quickly, so they can start testing it on real-life production data. I'm seeing a lot of teams shift. Now that prompting model is so fast, I'm seeing a lot of teams work to figure out how to deploy much quicker as well. And the implication is, from seeing for a lot of prompting workflows, the theme is iterate faster. So I'm seeing teams use very fast data-centric iterations to edit the data very quickly. And also, if prompting takes only seconds, you can frequently check how it's doing and edit your inputs and guide it. And that's why I said one of our early testers, she told me physical conversation, felt joyful. With physical conversation where you frequently, every minute or even every 30 seconds or something, check the system's understanding and feed the new data to guide it. I'm also seeing more teams start to hit partial labeling. Take a minute, label what you can in the label in a minute, and then go ahead and run it, see what happens, and then iterate from there. So no need to exhaustively label every image in advance. And then This might be a bit more controversial. I'm seeing more teams skip the test set initially. And I know in academic research, this test set is a really sacred thing. Got to collect a test set, validate our models, benchmark against other applications. And I know I'm saying something a bit controversial, but I am also seeing for a lot of applications, it is safe to develop a less vetted model. And this is absolutely not all the case. Responsible AI is important. Some of AI has risk of harm. Don't deploy unvetted models if there's risk of harm. And do take responsible AI seriously. And in many manufacturing examples, if you're inspecting, say, bits of metal, and you can deploy in the so-called shadow mode, so there's still a human inspecting the bits of metal, but the AI system is just quietly making predictions, but its predictions are not actually used. And it seems like there's not much of a risk of harm in that case, or much less of a risk of harm. Then I'm seeing teams in that setting deploy a model very quickly and then test in production, because the best test data, right, sometimes is production data. You just get rid of a lot of the problems of concept-driven data drift, and you can get it working pretty well that way. And only if you then need to eke out additional accuracy, those additional few percentage points of performance, then only optionally invest in the time and effort to collect a larger test set later. So I'm seeing this whole teams as well. So just to summarize, I'll jump and take a few questions. I'm running a little bit late, apologies. To summarize, I think text prompting is transform NLP. And I think visual prompting is an exciting emerging path to take these ideas from text to computer vision. Different researchers, different groups are working on different ideas to approach this, but I want to share my take on what's key to keep in mind for visual prompting. First, an easy UI. So visual prompt, I think, should be a visual task specification that's quick and simple and easy to give. And then second, I think it's important that the system give you results back quickly. One technical note, I don't think some people conflate, tend to put together visual prompting with sort of in-context learning and learning using only inferences with no weight updates. That's not how I view visual prompting. I think many implementations are possible. You can do many different things on the back end, but the key is to get a result back quickly, because that UI implication means that if it's easy to update or change a prompt and it get results quickly, then it can iterate very quickly to improve the system. And in fact, the UI is important, because if you think about ChatGPT, it was really that, OpenAI had a fantastic UI that was instrumental to making ChatGPT take off. And then I'll take questions in a second, but after this presentation, I hope you also check out our new visual prompting software that we just released today, that we're just releasing today at Landing AI. And I hope you will let us know what you think, and hopefully we can all collectively keep on working to expand this direction in computer vision and make this work better and better. Let's see. Thanks for sticking around with this video. Let me go to the questions. And try to take a few questions before we break. Cool. Oh, yep. Is visual prompting similar to SAM? Is related. I think the SAM work was fantastic, but it is very different. Sorry, I would say that in my mental ontology, I think SAM was one really nice work of using a visual prompt for the task of image segmentation. Our application is quite different. In SAM, if you have one picture, you prompt that picture, you get a segmentation back of that one picture. Whereas we focus on a lot of our customer use cases in manufacturing, life sciences, aerial imagery, and so on, where you want to prompt one image and get back results and classifications from a lot of different applications. But I think SAM did a great job with the image segmentation task. Second question, how is prompting AI different than traditional AI? Although ChatGPT can use for prompting, but instead of trained using traditional methodology. Yeah, great question. I think even for text, what happens in prompting has evolved, right? I think in the past, people were using large language models that would predict the next word on the internet or from its training corpus, and then we switched to models that can try to follow instructions. So even for text, the way you prompt text models has changed dramatically in the last 6 months or something. And so I think that the UI is still evolving and being innovated on. I think the foundational technology is often a very large pre-trained text transformer or visual transformer, but then we can build additional layers on top of that to expose, the functions that we want. Let's see. All right, let me just get, yes. Once the computation is complicated, we do multiple things on the back end. We actually use multiple vision transformer models on the back end that let's see. Traditional AI could be deployed in embedded device with model compression, fine-tune training data. Yes. So good question. So we have had a lot of customers that would train a model of us and then have to download the model to an edge device and run it. So Landing AI actually offers a software tool that we call Landing Edge that lets you train a model in the cloud and then download the model to the edge and then run it on the edge. And then we're still figuring out some of the complexities with that, with visual prompting. And I should have said visual prompting software releases in beta. So I think, what can be deployed at the edge is something we're still working to figure out. Similar to text prompting, I've been seeing very exciting work with some open source models, like I think GPT-4All lets you run a very small, relatively model-sized large language model locally on your computer, and I think those things are being figured out as well for visual prompting. Can visual prompt be used to track an object in a video instead of a single static image? Let's see. Good question. I think eventually, yes. Our software does not allow us to do that right now, but I think these would be exciting future directions to work on. Well, just take couple more questions and we'll wrap up. How's visual prompting different from weakly supervised models? How to adjust the reliability of such models after deployment? So I think that it's a good question. I think that a lot of this is about the UI, I think. And I think the fact that we can design a system where you can provide, maybe you can call the prompt one form of weak supervision. In terms of terminology, maybe you can think of, don't know, maybe it's okay. I'm not sure if you think of prompting as one form of weak supervision, but I think that we've seen for text prompting, the fast specify something, get the result back, and then change how you specify it almost in real time. That helps significantly in terms of developing, in terms of developing a deploying model quickly. All right, let's take one last question. How different is visual prompting from annotating poly images? Oh, I think that, one specific difference would be the fact that we can use partial labeling and the fact that it runs so quickly, right? I think that, with the Petri dish example, well, I think that, yes, maybe if you want, you can think of a system as something that allows only partial labeling and that allows us to take and put a partial label, that's a prompt. And then I think there are different ways you can imagine implementing this on the back end. And I think the key is when everything, is optimizing, works quickly, because that's a pretty miraculous, pretty nice and efficient UI. All right. Interesting. Someone says, does learning data engineering benefits to be a better data scientist? I think yes, data engineering is very important, especially data-centric AI. And I think one nice thing about visual prompting is it's so quick to prompt it, see what happens, and edit the data, get another result, and iterate from there. All right. So I'm now running a few minutes late. Thank you for sticking with me. It was nice to see you all on this call, and thanks for everyone that posted questions. We try to answer some additional questions in the online Q&A forum, but I hope you will jump online and give it a shot and try out the visual prompting software on Landing AI. I would love to hear what you think. So let's wrap. And thank you everyone that asked a question or that joined us or watched this video.